We are going to use this Awesome Chocolates database to understand how to build SQL joins. Refer to the video description to download the dataset and install it into SQL Server or MySQL. Let's take a look at the tables that we have here. We have got 4 tables: shipments, products, people, and geography. Let's see what is in the shipments. The shipments table shows us all the shipments that are done at Awesome Chocolates. So each row is one shipment. For example, here is a shipment of SP01, that is the salesperson, shipping P04 product to G4 geography on the 1st of January 2021. And this is the details of that shipment: 495 boxes of shipment, and the amount is $8,414. Given this information, let's say your boss asks you, can you tell me all the shipments that happened for Orange Choco? Now, we are not able to answer that question with this data alone, because nowhere in this data we know about the name of the product. To get the names of the product, we need to go to the products table, and here we can see that, for example, Orange Choco is actually P09. So to answer such a business question, you have 2 pieces of puzzle. One is your products table that gives you the information that Orange Choco is P09, and then the shipments table that tells you all the shipments that happened. Given these 2 pieces of puzzle, you can then combine them to answer that question. That is really what joins are all about. If you think your products table is this circle and your shipments table is this clumsily drawn circle, then to answer the business questions, we need to combine these 2 circles on a common attribute. In this case, the common attribute is the product ID. So we take the same product ID here and map it to all the products that have that same ID, all the shipments, using a kind of a connection or a join. That's what SQL joins refer to. There are different ways to join this information. We have got left joins, right joins, anti-joins, and all sorts of things. I'll talk more about them later on in this video. But for now, let's go ahead and combine this data with our very first SQL join. So here we would like to see the shipment information, but along with the names and categories of all our shipment products. If I simply say select star from shipments, we are only going to see the actual transactional information, but not the names of the product or the category of the product. To join the products table, we can just take out all of this and then put from shipments and then give it an alias and then say join, that is the keyword, products PR on PR.product ID is equal to S.product ID. So this is the join criteria, and that's how you specify. You say join the name of the table, an optional alias for it, on, and then the criteria of your join. Once you have built that, you can go back and specify all the fields that you want. So let's say we want to see the S.date, PR.product name, PR.category, PR.product ID, S.product ID, and then S.amount. Let's execute this. And here we can see all the results of our shipments along with the name of the product and category. You can also see that the ID column from both tables matches. So P04 here is equal to P04 there. Let's try this again with shipments with salesperson name and team. So here I have got a people table that has all the salesperson names, their ID numbers, team, and location of that person. And we would like to combine this information with our shipment data. So we'll say select from shipments S join people P on P.spid is equal to S.spid. And then again, we want the same kind of fields. So S.date, P.salesperson, P.team, S.amount. Let's just stop there and execute this. And here we will get all the information. You can see that certain people do not have a corresponding team. So the team value is null. They don't belong to any team. And that also shows up here nicely. For our third example, let's get all the shipments where the category of the product is bars. So here we can kind of reuse the same join that we did earlier. So I'm going to copy that query and paste it here. At this point, this is just going to give me everything. So if I run that, I get all the shipments that happened, but we don't want all the shipments. We just want to look at bar category alone. So once the join is done, then we can introduce a where clause where pr.category is equal to bars. And when you run this, you will see just the category of bars and the corresponding shipments. So we can see that this is actually 3,816 rows. Whereas if I exclude the where clause and run this query, we get 7,617 rows. For our fourth example, we are going to go with a word play. We do have a salesperson called Barfoni. So we would like to get all the bar shipments. Again, I'm going to copy the join that we did earlier with the people table. So we have got date, person, team, amount, and the join is on the people table, and introduce a where clause here where p dot salesperson is equal to, and then specify their name, Barfoni. And when you run this, you're going to get just the Barfoni sales or shipments. So that is the bar shipments. When you are doing something like this, you have an option of writing the where clause, or alternatively, I'll copy this and paste it here. You can move the where clause into the join itself. So here you can say join people p on p.spid is s.spid and p.salesperson is Barfoni. So the join criteria also introduces an extra condition there itself rather than using it as a where clause. Let's make a note of how many records the first query returned. 304 rows. Now let's see how many the second one would be. 304. So both of them kind of work in the same way. It's just that one of them uses a where clause, another one imposes the condition as part of the join itself. For our sixth example, we want to get all the shipments where the category is bar and the person name is bar. I call this as bar shipments. It's a little bit of fun wordplay, but an interesting example that shows you how to combine and join multiple tables in one go. So we're going to copy one of these things. I'm just going to copy this join here, paste it. So this join alone gives me all the Barfoni shipments, 304. But what we want to do is we want to further reduce this just to bar category. So we need to again join one more table. So we'll say join products PR on pr.product ID is equal to s.product ID and pr.category is equal to bars. So in this case, the conditions are all in the join, and when you run this, you will get a condensed set of 150 rows. We are not seeing the category name here, so I'm going to add that field here. And now we can see that the name of the shipments is always Barfoni and the category is always bars. You can either write these conditions as part of the join, or normally when I'm doing this, I like to keep my join simple and introduce these kind of conditions as my where clause. So another way to write this is introduce a where clause after all your joins are done, and then say p.salesperson is equal to Barfoni and pr.category is bars. The net result will be same. You'll still get the same 150 rows, but this is a little bit cleaner and you can actually adjust these variables depending on what else need to be done at the time of request. Another bonus tip here is once your query is doing all the joins and where clauses, you can still go ahead and apply anything else on top of it. So for example, you can order this data, order by s.amount DESC. So then this 150 records are shown in the descending order of the shipment amount. So highest amount goes onto the top and lowest amount goes to the bottom. Let's take this concept to the next level by looking at bar shipments and then group them by month. So rather than looking at all the individual shipments, all the 150 shipments, we just want to see it how much has happened every month. Let's build this query from scratch rather than copy pasting so that you can see the whole process again. So we'll say select. We don't know what these fields will be, so we'll come back to that from shipments S, and then we'll need two joins, one for product table and another for the people table. So join products PR on PR dot product ID is equal to S dot product ID. Likewise, join people P on P dot SPID is equal to S dot SPID. So now that all the joins are done, we can go back and specify what fields we want. We want the data to be grouped at a monthly level. Now, if you look at the actual information, we do have daily shipment data. So we know what is the year, month, and day of the shipment. As we don't need that level of detail, we need to calculate the month value from the date. This is where, depending on the SQL that you're using, your functions might change. I'm right now using SQL Server, so I'm going to use the format function and take my s.date and then format this in MMMYY format, and then give it an alias called month. And then we would like to see the data totaled at a monthly level. So the data that we want is how much is the amount and how many boxes they have shipped. So we'll say sum of s.amount. We'll alias this as sales. You don't have to always write the word as. If you space and just put that, that will work as well. So now that the join part is done, let's introduce the where clauses. If I don't specify the where clause and just leave it at that point and then say group by and copy this. Let's say if I run this now, then I'm going to get the total sales and boxes that happened across the business. Whereas we are not interested in that. We just want to look at bar and bar combination. So let's go ahead and add those where clauses. Where pr.product, no, it's category, pr.category is bars and p.salesperson is bar funny. And now if you execute that, then this is going to give me the information for just that combination. So far, we have only been joining the data. But now let's understand the concept of left join and right join. Going back to our ugly circle diagram, let's say we have got two tables. So this is my products table and this is my shipments table. Overlapping of these two tables indicates that they are joined. So far the way we have been joining is wherever there is a match, we are seeing that information. Now in a business situation, normally this overlap is really big. So the circles are not partially overlapping. In almost all the situations, the circles fully overlap. So you have got products table and shipments table. All the products that you have are always being shipped. So they kind of match. But occasionally what could happen is you might have just launched a couple of new products that never get shipped. So in such case, you can also use a left or a right join to kind of extract the information where some parts of the joins are not done. Most of this would seem quite abstract when you learn it initially. So I'm going to show you a few examples and hopefully that all makes sense. Here is a quick reminder of our products. We have got all these products P01 to P24. Choco Jello and Butter Pops are new products that we introduced. We have not made any shipments on these products yet. So you can see that P23, P24, if you actually go and where clause them, you will find that there are no shipment records for them. So we'll come back here to our queries page, and what we want to do is do a left join and get the shipment information for all our products. So for this first left join exercise, we'll go from the perspective of products. So we'll say select from products table, Notice the difference here. I'm selecting from products table rather than shipments table that we are usually doing all this while. PR, join shipments S on, and then we are going to write our criteria and then change the join wording as well. So S dot product ID is equal to PR dot product ID. So rather than saying join, I'm going to say left join. And then we'll come back here. We are going to say S dot date, PR dot product, PR dot product ID, S dot product ID. And let's just put S dot amount as well. And let's just run this and we'll get 7,619 rows. All the shipments that happened, the overlapping part, they all come. And somewhere in this list, fortunately at the end, you will see Butter Pops and Choco Jello, the new products that we added. They just have the record on the product side of information. So they have the name and the product ID, but there is no corresponding product ID on the shipment side. They don't have any amounts or dates. So this is what a left join enforces. Because we are saying left, this information has come up. Imagine if I didn't say left and just run this as it is, then we will lose those 2 rows. So now we are back to 7617 and that information is not there. If you don't say left join, then it kind of defaults to the overlapping part, or normally we call that as inner join. But again, it is superfluous. So you don't need to say inner join. You say join, then whatever is overlapping, that's what you will get. But if you want to get the non-overlapping parts from either left side of the query or right side of the query, then you would use left join or right join. One thing that I found as a student of SQL many years ago when I was learning all of this is, even though we are using the words left and right, because the queries are written up top down, sometimes the left is really enforcing the top part. So here left is actually ensuring we get all the products which is above in the query, and then right would enforce we are getting all the records from the shipment side. So one thing that kind of mentally helped me understand this concept better is, rather than saying left and right, I would think this as top and bottom join. I don't know if this helps you, but it was kind of helpful for me to have that perspective. Our 9th example is on anti-joins or anti-joins. Again, this kind of thing is a little bit tricky to explain abstractly. So we're going to go with a practical example, which is which products haven't been sold at all or shipped at all. And obviously we are expecting to see those 2 new products as a result of this. So the way to get this is we do the same thing as a left join, copy that exact query, but this time we add an extra criteria here, which says the product ID needs to be null. Because if I run this, you can see that the product ID will be available on the product side of the table, but not on the shipment side. So if there is a product ID existing, but there is no corresponding shipment product ID, then those products are not shipped at all. So here we can now write a where clause where s.product ID is null. And then it's going to filter this down and you're going to see those products. Of course, because we are querying for date and other stuff, all of those will come as null, but you can take them out. You can say, just get me only the product side information. So product dot category and all of that. And you can query for that and you will get the Butter Pops and Choco Jello information here. So these are the products that haven't been shipped at all. A common pattern that we use in business is we use this kind of a thing to answer questions like which customers haven't visited our website in the last 7 days, or which patients haven't booked a follow-up appointment this month. You know, those kind of things where you want to join to the other transactional side of things, but then you're looking for all the nulls and then report on them. For our 10th example, I have got a complex query. Did we ship all the products on 1st of February 2022? Let's go step by step and understand how to answer these kind of questions. First up, I just want to see which products were shipped on the 1st of Feb 2022. That kind of a thing can be answered directly by saying select star from shipments s, where s dot date is equal to, this is going to give you all the shipments that happened on the 1st of February. So on 1st of February 2022, we made 23 shipments, and this is how it looks like. Now you can see that the product ID column contains all the codes, and you can see, for example, something like P12, there were actually 2 shipments or probably more than that. So some repetitions. Naturally, 23 rows and some repetitions. So we can assume that certain products were not shipped at all on that day, but we would like to investigate and get that information clearly. You can then take this and join this onto the product side. So we can say join products PR on pr.product ID is equal to s.product ID. And you might think, what happens if I just say star at this point, not specify any fields? Then what happens is you're going to get all the fields from both tables. So everything comes here, all the 23 rows, but all the corresponding product columns are also here. But the question is not to see this information. It is to see for each of our products whether we shipped them on 1st of February or not. So even if there is a single shipment of 1 box of that product, we want to just say yes, else no for each of our products. So this approach of going from shipments is not going to work. We need to go from the products table direction. I'm going to leave that query there and then write another query here. So this time we are going to start our journey from the products table. Select from products PR and then join this products table to my shipments table. But because we want to keep everything in the products table as it is, we are going to go with a left join. Left join shipments S on. And if we execute this, we are going to get all the shipments. I forgot to put the date criteria, so I'm going to add that now. Where date is this, and let's just run this again. And then we are going to get the same 23 rows again. You might say, what happened? We enforced left join. What happened to those other products that were not shipped? That's because after the join has done, then the where clause kicks in and it is kind of filtering down to that date. So on that date, if that product was never shipped, then it's not going to show up. One way to avoid this is to move this date clause into the join itself. So if I say it like this, notice what happens. You're going to get 31 rows rather than 23 because now the left join is adding both conditions there. But because it is a left join, anything on the product table still remains. Whereas with the where clause, the join does its job and then where clause comes in and kicks in. So we'll see all these nulls. Wherever it is null, that means that product was not shipped on the 1st of February 2022. Again, we don't want to see this kind of information or that level of detail. We just want to see for each product whether it was shipped or not. Yes, no kind of a thing. So what we can do is we can take this query and then we can store that into a variable and then use that variable somewhere else. So this is where the advanced concept comes in. We can say with open bracket and put this query into that and then give this entire thing a name. So I'm going to call this as febprods as. So with febprods as this query. And now that we have built a kind of like a variable that holds this subset of results, we can then use febprods elsewhere to build that next criteria. You can say select from febprods and we would like to select the product name. So the product and then sum of the amount column as sales and then group this by product. Let's just see what this results. I'm getting an error here. It says product ID was specified multiple times in the febprod. This is because we are saying select star. So it was kind of getting the product ID from both tables. So it's not a good idea to use select star there. I'm just going to change this to a list of column names. So we're going to say pr.product s.amount s.date. Let's just stop there and let's run this again. So this is going to give me for each of our products, how much was the sales that happened on the 1st of February. Wherever it is null, it was not shipped. If there is a number, then it is shipped. If you want to go a little bit further and say yes, no at this point, what you can do is you can add an extra calculation here. We can define that as, for example, sales status is equal to, and then we can use the case operator to build that kind of a condition. So we can say case when sum of amount is greater than 0, that means there has been some amount, then shipped, else not shipped, and then end this case. So at this point, if you run all of this together, you're gonna get not shipped or shipped kind of a flag next to it. Normally when I do my analysis, my intention is to get the numbers here, and then I take this query into either Excel, Power BI, or Python, or somewhere else. So I can build that kind of an extra column there as well. I don't need to write that into SQL, but occasionally you may have to write that as part of the SQL itself. So let's take a closer look at this query again. You can see that we have built a subquery kind of a thing, and then put that into febprods as a variable, and then referring that in elsewhere to generate the group by. You could also solve this with some other types of functions in SQL, but normally this is how I would do it. So I hope you found all of these 10 examples on SQL joins fairly helpful. I do have some homework assignment for you. These are 5 SQL queries that will help you test your join knowledge. Most of them are covered in this video, but there are some concepts that are not covered as well. So feel free to check them out in the video description below and go ahead and solve them. Let me know how you're going in the comment section of this video. And if you want to understand how SQL is going to help you in the next part of the data analysis journey, that is analyzing the data and visualizing the results, I have a live stream of how SQL and Power BI can be used together. Check it out. It shows up on the screen. I'll catch you there. Bye.